So good morning, everyone. Switch on your cam quick. Today's boards lecture only. Yeah, today's boards lecture. Okay. Today, I think we'll complete the boards part. Today itself will complete the boards part, and then we'll start with the CET from the next class. Okay, now listen. Last class, I told you the formula for capacitor was C is equal to A epsilon naught by D. Have we done this part? Check on the screen. What is that? Have we done this part? Yes or no? Check your notebook.
Yes, sir.
We have finished this part? And we have done this problem?
Yes, sir.
Okay. And we have finished energy stored in a capacitor?
No, sir.
No?
No, sir.
Okay. So write down energy stored in a capacitor. Let us target boards today, completion of boards. Energy stored in a capacitor. Write down the next topic of capacitor. Energy stored in a capacitor. Energy stored in a capacitor derivation, little important. And in this derivation also, they have asked energy stored, but we will find work done. And whatever answer we get for work done, we will conclude that itself is the energy. I will repeat. They have asked what is the energy stored in a capacitor, but we will not find energy stored in a capacitor. We will find work done. And finally, we will conclude that work done itself is the energy stored in the capacitor. Therefore, even though the side heading is energy stored in a capacitor, we will find out the work done in a capacitor. Is it clear? We will find out the work done in the capacitor. And the derivation is very easy. Now listen to me. We know the formulas here. You know the formula Q equal to CV, correct? Everyone knows the formula, basic formula for capacitor. The most basic formula for capacitor is Q equal to capital C, capital V. What is Q? Charge. What is C? Capacitance. What is V? Potential. Or I can say V is equal to Q by C. Check. We know that V is equal to Q by C. Now, when you're charging a capacitor, for example, when you're charging your mobile, so suppose your mobile is at 0%. When you keep your phone for charging, immediately it won't become 100%. Can I say from 0 it becomes 1, 2, 3? Can I say it crosses all the numbers to reach 100? Okay?
Yes.
That means 0%, 100%. What is the condition in between called? Can I say the condition in between is called intermediate condition? Can I say the condition in between is called intermediate condition? Therefore, can I say if V is the final potential, means 100% charged, small letter v, listen to me carefully, small letter v, it is the potential while charging. Q is the final charge, small letter q is the charge while it is still charging. Do you understand? So listen to me. You know that V is equal to Q by C, but this is the final formula. Means it is the complete potential, complete charge, complete capacitance. But while it is charging, this is final charge. While it is charging, let it be small letter q. This is final potential. While it is charging, let it be small letter v. Therefore, can I say this is the formula when it is completely charged, and this is the formula when it is charging? Just think about it. Let me repeat. All of you look at the screen. V equal to Q by C is the formula when it is completely charged. This means final potential. But while it is charging, let it be small letter v. And this is capital Q, means it is completely charged. While it is charging, let it be small letter q by c. Therefore, can I say this formula is the final formula and this formula is the intermediate formula? Got it? This formula
Yes,
is
sir.
the intermediate formula. Okay. After that, I'll tell you what you need to do. So first, write down the side heading. Write down the side heading. Energy stored in a capacitor. Written the side heading. Below that, write down. We know that, same way, write down. We know that capital V is equal to capital Q by C. Write down. We know that capital V is equal to capital Q by C. We know that capital V is equal to capital Q by C. And write down till here. See, listen to this. Let the initial charge be 0. Let the final charge be capital Q. And it, while charging, it is small letter q. Similarly, let initial potential be 0. Let the final potential be V. Let the potential while charging be small letter v. Therefore, during intermediate stage, small letter v is equal to small letter q by c. Till here, all of you write down. Till this particular line start. The main heading is energy stored in a capacitor, and below that, write down from here till here. Okay. Now listen to me once. Listen to me once. Well, I'll finish this page, then you can copy the whole page. Okay, just listen to me once. Look at the screen. We know the formula W is equal to VQ. From where do we know this formula? W is equal to VQ?
Yes,
from our few table, correct? From our few table, V is equal to W by Q or W is equal to VQ. Why am I using this formula? I'll repeat once more. Even though I have to find out energy, I will find out the work done. And finally, I'll conclude that work done is equal to my energy. Even though I have to find out energy, I will find out my work done. Then I'll conclude that work done is my energy. Therefore, the main formula for work done is V into Q from our few table. Now I'll differentiate both sides. Differentiation of W is dW. Differentiation of capital V, that is the overall charge, that is overall potential, is intermediate potential, and differentiation of Q is dQ. Remember, if W is equal to VQ, and if I differentiate both sides, W will become dW, capital V will become small letter v, which is nothing but dV, and Q will become dQ. And small letter v, look at the screen, small letter v is nothing but small letter q by c. Therefore, dW is equal to small letter q by c into dQ. With that, we have completed the whole page. I want all of you to understand the complete page and write it. Any doubt on this page, let me know. I'll explain the whole page again in 1 or 2 minutes. First finish writing. I'll explain the whole page again. Okay, start writing. Okay, let me start again. I'll just explain this page again. Okay, look at the screen. I have to find what is the formula for energy stored in a capacitor. That is the main heading. And finally, I'll have to get a formula for energy itself. But like most of the derivations in physics, where energy is asked, I will not find out energy, I will find out work done. And finally, I'll conclude that that work done is equal to my energy. Therefore, in my derivation, I want to find out what is the work done. So with that, I will start with the basic formula for capacitor. Please look at the screen. That is the first thing. I know that my capital V is equal to capital Q by C. But my capital V is my final potential. But once my capacitor is charging, that V will be small letter v. And capital Q is the final charge. While the capacitor is charging, it is small letter q. And C will remain C. Therefore, please look at the screen. This is my final formula for capacitor. And this is the formula for capacitor while it is charging. So final potential is V. While it is charging, it is small letter v. Final charge is Q. While it is charging, it is small letter q. Capacitance will remain as capacitance. Then I start with the formula for work done. W is equal to VQ. I differentiate. Differentiation of W, dW. Differentiation of capital V, small v. Differentiation of Q, dQ. dW as it is. V can be written as small q by C dQ. Now comes the main part. Now listen, now comes the main part. I need the value for work done. I need W. But on my screen, I have dW. I need W. And on my screen, I have dW. Tell me, what is the best way to get W from dW?
Integrating.
Integration.
You have to do integration. Therefore, if I integrate both sides, now just look at this. This is directly from your textbook. Now, if I integrate dW, I will get W is equal to, if I integrate the right hand side, can I say here I'll integrate and here I will integrate. Integration of dW will be W. Here integration will be integration of Q by C dQ. The same thing that they have written here. Just check. And integration, if you see, from where to where they have done check. I am doing integration with respect to charge. What is the initial charge of a capacitor? 0. What is the final charge of a capacitor? Capital Q. Therefore, my integration is between 0 to capital Q. Okay. Therefore, listen to me carefully. Integration of dW is W is equal to On the right hand side, integration sign will come Q by C. That integration is from 0 to capital Q. Okay. Now, left hand side as it is W. Can I say since integration is with respect to charge, 1 by C will become constant, it will come outside the integration sign, correct? Since integration is with respect to charge, 1 by C will come outside. And what is integration of Q dQ? Integration of Q dQ is same as X dx. Integration of Q dQ is same as X dx, which is X square by 2. Therefore, over here I will get Q square by 2 between the limit 0 to Q. Between the limit 0 to capital Q. Therefore, 1 by C as it is. Inside the bracket, capital Q square by 2 minus 0. Or I will get the answer Q square by 2C. Till here, did you get the answer?
How did you get Q square by 2?
I will show it to you on a blank page. Tell me, everyone clear till here? All of you.
Yes, sir.
Okay, everyone clear till here? dW is equal to Q
Yes,
by
sir.
C dQ. Then what I'll do is, I will only show you on a blank page. 1 minute. See here, all of you. Where did we stop? We stopped at dW is equal to Q by C dQ, correct? Till here, everyone clear? That is the end of the first page.
Yes, sir.
Now what I will do is, I will integrate both sides. And when I'm integrating charge, I have to integrate from initial charge, which is uncharged, 0, to final charge, which is capital Q. Is it clear? All of you, look at the screen now.
Yes, sir.
Now stop, let me do step by step. Now integration of dW will only be W, because integration and differentiation will cancel, equal to, since I'm integrating with respect to charge, 1 by C will come outside. It will become integration of 0 to capital Q, Q dQ. Okay?
Yes, sir.
Then W is equal to 1 by C as it is. Integration of Q dQ is Q square by 2 between 0 to capital Q. Because integration of X dx is X square by 2.
Yes, sir. Got it.
Now, W is equal to 1 by C and 2 outside, because 2 is a constant, Q square between 0 to capital Q. Or W is equal to 1 by 2C Q square minus 0 square. Therefore,
Q square by 2C.
Q square by 2C. This is one of the formula, but not the final formula. So make a note till here. I want all of you to understand every step that I have done. This was the last step of the first page. Then over here, this step, this. Tell me if you have understood all the steps. Pure integration, nothing else. Come till this step. W is equal to Q square by 2C. Come till that step. Finished writing till here?
No, sir, wait. Yes, sir. Sir, wait, not finished.
Now
Done,
finished?
sir. Done.
Okay. Now it is W is equal to Q square by 2C. Now please look at the screen. W is equal to Q square by C. Correct? Now, look at the formula. Do I know Q is equal to CV? If I substitute that, I will get W is equal to C square V square by 2C. 1C and 1C will cancel. Therefore, work done is C square. Therefore, my internal energy U is equal to, this is my final. Even this is one of the formula, but this is also correct. But many times you see this is the standard form. Half CV square Joule. This is the answer. This is the answer. Energy is equal to half CV square Joule. Finish writing this much?
Sir, can you repeat the last step?
So till here, this was your last page, correct? Q square by 2C. Now I substituted Q equal to CV. So instead of Q square, I took CV square, which is C square V square by 2C. Therefore, 1 square and 1C will cancel, and I'm left with half C V square. Okay.
Sir, and how did you equate it with energy? Just
The
because it has
total work done is same as our internal energy. Both are joule. Internal energy or energy stored. And this is not only one derivation. You might have seen in part 1. I don't know how many derivations have done in part 1 till now. But whenever energy is asked, you always find out work done and you finally equate work done equal to energy. Not only this derivation, many derivations in physics. Finished? Now, the main thing from this derivation is the result. What is the result? Energy stored in a capacitor is half CV square. So in future, if I ask you what is energy stored in a capacitor, you will tell me it is half CV square. Therefore, please look at the screen. The main formula that you have learned in capacitance is Q equal to CV. This is the first formula that you have learned in capacitance, which is the most basic formula. Then you have learned capacitance in series is 1 by CS is equal to 1 by C1 plus 1 by C2 plus dot dot dot. Then you have also learned capacitance in parallel CP is equal to C1 plus C2 plus dot 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 Cn. Then you have also learned parallel plate capacitor capacitance formula A K epsilon naught by D last class. Today you learned energy stored in a capacitor is half CV square. These are the main formula for capacitance. Just check. These are the main formula for capacitance. Okay. Everyone switch on your cam. So this is the second page from the text. Tell me if you have understood completely. That till the last step. That is half CV square. Now check the whole derivation that you have written for today and let me know whether you can derive on your own up to the final step. That is the energy stored in a capacitor is half CV square. Message me and let me know. You need any clarification, any step, understood, repeat, let me know in the message. Okay. Okay, perfect. So let me go to the next topic. Electric potential due to a dipole. Have we done this in the last class? I don't think so. We did only capacitors, correct? So it is just one formula. So write down the side heading. Write down the side heading. Electric potential due to an electric dipole. Write down side heading. Electric potential due to an electric dipole. Write down the side heading. Electric potential due to an electric dipole. Now look at the formula. See this. You directly have the formula. Electric potential due to an electric dipole is V equal to, forget VC, V equal to 1 by 4 pi epsilon naught P cos theta by R square, where P is your electric dipole moment, what you have studied in 11th standard. And the formula for P is Q into 2L. Do you remember this formula from last year? Electric dipole moment is charged. Even this year we did the same formula. Q into 2L. What is the 2L stand for? What does 2L stand for? 2L stands for dipole length. Magnetic length in magnetism. Over here it is just dipole length. Okay, Balaji. Here it is only dipole length.
Yes, sir.
Okay. 7 times over, yawning. 3 more times, then you can sleep. Okay, just 3 more times. Okay, we'll wait for you. Okay. Now, P is equal to Q into 2L. Therefore, you have to write the main formula. What is the potential due to an electric dipole? So write down. As and when I dictate, you write the notes. Write on the side heading. Electric potential due to an electric dipole.
Sir, we don't have derivation for this formula.
No, we don't have derivation. Not only this, not only because it is deleted portion, you don't have the derivation in your 12 boards, even if it was not deleted for this particular.
Sir, so this entire topic is deleted. Electric potential due to electric dipole.
It is not deleted. It is not deleted. Little bit of topic is deleted, but even if the topic was not deleted, the main topic, derivation was not a part anyway for your syllabus.
Okay, sir.
Electric potential due to an electric dipole, new topic. So write it properly. Electric potential due to an electric dipole. And write down the formula. V is equal to 1 by 4 pi epsilon naught. V equal to 1 by 4 pi epsilon naught into P cos theta by R square. Into P cos theta by R square, where P equal to dipole moment, where P equal to dipole moment, where P equal to dipole moment. And the formula, please look at the screen, and the formula will be, it is anywhere written, P is equal to Q into 2L, where P is called your dipole moment, and the formula for dipole moment is Q into 2L, where Q is charge and 2L is the dipole length. And 2L is the dipole length. and R. Yes, Balaji. Number 8. Good. 2 more. And R is the distance of the point from the center. And small letter R is the distance of the given point from the center. And small letter R is the distance of the given point from the center. Small letter R is the distance of the given point from the center. Okay. Small letter R is the distance of the given point from the center. Now there are 2 cases. Listen to this. Everyone look at the screen. If the point is on the axis of a dipole and if a point is on the equator of a dipole. Now I know any point on the axis, theta will be 0 because it is on the axis, and any point on the equator, theta will be 90. Correct? And
sir.
you know already from 11th standard that equator is perpendicular to axis. Equator is already perpendicular to axis. Therefore, if axis is 0, equator will be 90. Now, look at this. If I take potential at an axial point, means any point on the axis, I know that theta is equal to 0. Now, if I put theta is equal to 0, tell me what happens. I will get cos 0. Cos 0 will be equal to 1. Therefore, can I say my formula will become 1 by 4 pi epsilon naught into just P by R square. And this is the maximum value of potential because any formula without trigonometric term becomes maximum. Therefore, you have written the formula, you have written what P stands for. P stands for Q cross 2L. Below that, write down case 1. In your notebook, write down below that case 1. Potential at axis. Write down case 1. Potential at axis. And below that, write down what I have underlined. Check what I have underlined. Nothing else, just what I have underlined. Here, potential at an axial point, theta equal to 0. Write down this formula and write down this thing. The maximum value of potential is at axis, theta equal to 0. Make a note.
Sir, the angle which we are taking for axis and equator, what is it with respect to?
Center of the dipole. For example, in magnetism also, if I had a magnet, okay, for example, this is north pole, this is south pole, and any line passing through north and south pole is the axis. Now, if I take any point on the axis, the angle it makes with the dipole itself is 0, same way. And any point on the equator, angle will be 90. That is the meaning. Any point on the axis and any point on the equator. This is with respect to magnet. With respect to electric dipole will be minus Q and plus Q. Same logic.
Sir, so in the earth, like in the electric dipole, the north and south, according to that, we have taken as the axis the horizontal line.
According to electric dipole, a line passing through both the charges, minus Q and plus Q. Because in magnet it is north and south. In electronics it is plus Q and minus Q. Positive charge and negative charge. Therefore, can I say if I want maximum potential, then the point has to be on the axis because cos 0 is 1. Therefore, I will get the maximum value for potential at axis. Now look at case 2. Everyone look at the screen.
Sir, do we need to write plus minus?
Do we need to write what?
Plus minus.
No, we don't need to write plus minus. It's only 1 by 4 by epsilon. No need to write plus and minus. Now case 2. Now look at case 2, all of you. Now look at case 2. Potential at an equatorial point. Case 2 is potential at an equatorial point. Now can I say at the equator theta is 90? Therefore, can I say if theta is 90, my entire value of V will become 0. My entire value of V will become 0 because cos 90 is 0. Hence, the potential at any point on the equatorial line of a dipole is 0. And this is the minimum value of the magnitude of potential of dipole. This is my second case. Potential at the equator. Right now, potential at the equatorial point, as I have written, V equal to 0.
Sir, in case of Earth, we consider equator as horizontal line. So in physics, we take the reverse, right?
For Earth, you're saying?
Yes, sir.
Earth, we consider it as a magnet. So there we take it as magnetic equator and we take magnetic axis. This is with respect to electrons we are doing, but the concept is same. But what you're saying for Earth, magnetic equator, we take it as horizontal, that is correct. But that is magnetic, okay? Not electric.
For electric, it will be vertical.
But Earth is not taken as an electron.
Yes, yes.
Earth,
Yeah,
what Earth is taken as a magnet. But if you are saying if Earth was taken as an electron and Sun is taken as a nucleus, that way then it would be vertical.
yes, sir. Got
Finish writing. So there are three formulae. One is a general formula. One is a formula on the axis. One is a formula on the equator. They are not different formulae. They are the same formula but different variations. When theta equal to 0 and when theta equal to 90. Last 30 seconds. Put a dot once you finish writing. I'll send after this class. I will share this PDF, all of you. Just two things. I'll share all the PDFs. I think there are 6 PDFs. And also, not my recorded lecture, but my other recorded lecture of complete electrostatics, which I have done it on the board. Okay, means I have taken recording while I was teaching on the board. I think I'll get that link and I'll send it to you. The complete electrostatics chapter, I have done it on a board and I have explained. So just look at that recording also. This anyway we are recording, but check that recording also. That was done last year with the last batch. You can check that out also. That will be better for you. Board is a little blur, but more or less you will understand the explanation. Okay, so there also there are 6 videos, but the entire chapter is explained from the beginning till the end on the board. Okay, so I will try to give you that link. This recording you can anyway take. That also link I will share it in this PDF also. Okay, done. Now listen to me. This is the question. Try to answer, then I'll show you the final working. Depending on the formula that you have studied just now, try to answer one by one. Give me the answer of A, B, and C. There are 3 cases. I can say the answer for case B will directly be 0.
Yes, sir.
Answer for case B will directly be 0. Now, answer for case A and case C, we'll have to get the answer. Start. Priyanshu, send that message to me over WhatsApp once. Yeah, I think I got, that's the link. Correct.
Sir, the final unit will be V, right?
Yeah, because it is voltage potential. Now let us start. See here. A short electric dipole has a dipole moment of, that means they have already given the value for P. Determine the electric potential distance also is given. So check. Please look at the screen. They have anyway given the value for P. They have given R. And you know, potential on the axial line will be this formula without cos theta. 1 by 4 pi epsilon naught will be 9 into 10 power 9. P is 1 into 10 power minus 9. And R is given as 0.3 square. Therefore, answer will be 100. And second part, I already told you that on the equator, it will be 0. And third answer, can I say, listen to this, can I say third answer will be half of the first answer automatically? Because cos 60 is half. Therefore, can I say in this formula, look at the screen, in this formula, 1 by 4 pi epsilon naught P by R square, we have already got the answer, into cos 60 is half. Therefore, answer for the third one will be exactly half of answer of the first one. Got it? This is the answer on the screen. Now try to get the answer. Make a note of your homework.
Sir, show the sum.
Example 8.16. This is your homework 1 and displacement current section. And you can refer to the homework also. Topic has been almost eliminated, but anyway, you can check it out. Okay. Make a note of the homework for today. First homework is example 8.16 and second is section 8.11. And your third homework also will be to complete the entire notes of electrostatics, because today we're going to complete that chapter. The third homework will be to complete.
Sir, show the upper sum.
What happened?
Sir, show the sum.
Yeah. I'll leave the sum on for 1 minute and then we'll go to the next topic.
Done, sir.
Okay, now we'll have to complete this particular PDF. So PDF started with electric potential at a dipole. We got this answer. We did a problem also based on potential of an electric dipole. Then this we have done last class itself, the various cases of a capacitor. Then we did this problem. We did the derivation of energy stored in a capacitor. Now, what is the final answer for energy stored in a capacitor? The final answer for energy stored in a
Half
capacitor
CV.
was half CV square. Now, based on that, we will have to do one problem. Okay, now this is the problem. That is example 8.19. Okay, now listen to this. See here, a parallel plate air capacitor has a capacitance of 3 into 10 power minus 9 farad. Everyone look at the screen. A slab of dielectric constant 3 and thickness 3 centimeter completely fills the space between the plates. The potential difference between the plates is maintained at a constant 400 volt. What is the change in energy of the capacitor if slab is removed? Now, the question is, what is the change in energy? So whenever change in energy is asked, it is always some final energy minus initial energy, or first case minus second case, or second case minus first case. That means whenever you are supposed to find change in energy, first you are supposed to find two energy. One is energy in one case, one is energy in other case. Then you have to subtract both the energies and get the answer. Okay, understood? So now I have to get two energies, and once I get two energies, I have to subtract them and I have to get the answer. Okay, once I get two energies, I have to subtract them and then I have to get the answer. Now look at the question again. So the first case, they have said a parallel plate air capacitor has a capacitance of this. That means the first case is air capacitor. And they have given you a capacitance. Now look at the screen. Now we will first find what is the energy stored in the capacitor with air. Okay, because that is the first thing given. What is the formula for air capacitor? Half C V square. Now is C given and is V given? Now can I say C is given as this value? Check everyone. 3 into 10 power minus 9 and V is given as 400. Therefore, can I say if I want to find energy of an air capacitor, it is half C V square, where C is of air. Now, can I say in this case, half is a constant. I know the value of C, I know the value of V. Tell me what is the value for energy of an air capacitor. Start and give me that answer first. We will go step by step. So give me this answer first.
Six into 10 raised to minus 7.
Others, give me the answer. People have given me the answer. Stop. Others who are still solving, give me the answer quick. Okay. Now, answer will be check. Are you getting this or not?
Yes, sir.
Yes, sir.
This is the first part of your answer. Everyone, please check whether you're getting this. Okay. Now, see the second part. Listen to me carefully. Now, a dielectric constant 3 is completely introduced between the plates, correct? A dielectric constant 3 is completely introduced between the plates. You know that if a dielectric is completely introduced between the plates, please look at the screen. Can I say the new capacitance is K times old capacitance because it is completely introduced? It is completely introduced. How do I know this answer? Because last class we have done this. Just check. Okay, last class we have done something like this, where if the whole space between the plates is filled with an insulator of dielectric constant K, the new capacity will be Ck. The new capacity will be Ck. Now, based on that, can I say if the old capacitance was 3 into 10 power minus 9 farad and something is introduced with the dielectric constant, is dielectric constant given 3? Can I say my new capacitance will be, check. Can I say my new
Sir,
capacitance
what
will
if it
be,
was partially introduced?
then the thickness was given, then I have to use the formula D minus inside
Yes,
the bracket, correct?
yes,
If it was partially introduced. There are all the cases, correct? Now can I say in this case, the new capacitance will be K times old capacitance. Old capacitance was 3. This time it will be 3 times 3. Therefore, can I say the new capacitance will be 9 into 10 power minus 9, new capacitance. Now, with this new capacitance, find the new energy. Find the new energy. Find the new energy means use the same formula again, half CV square. In this case, C will not be 3. C will be 9 into 10 power minus 9. Understood? And give me the answer for energy. Start. It is anyway given. Tell me if you're getting this answer. So first you found out old energy with air, then you found out new energy. First tell me, are you getting the answer for new energy? 72 into 10 power minus 5.
yes.
So you got the new energy, you have the old energy, then change in energy will be new energy minus old energy, and the answer will be 48. Just check because it will be 72 minus 24 because the old energy was 24 and the new energy is 72 and the answer will be 48. Check change in energy. Once you are done with the whole problem, just put a dot because now the whole problem is very easy. The formula is half CV square. 2 times you have to use. One in terms of old C and one in terms of new C. Okay. Okay, I'll give you some more time.
Yes, sir, got it.
This is your next homework. Make a note. MCQ1. Make a note. This question we will have to do. This is also a JEE question. And this is also an MHT-CET question. And this is also a boards question now. Okay. So look at the question, look at the options, try to do it. Then I'll also do it on the screen. Okay. Start. Try to solve this question and see what is the right answer. Then I'll show you the answer. Okay, see here. The main clue that they have given, see here, a slab of material of dielectric constant K has the same area A as the plates of a parallel plate capacitor of thickness 3 by 4D. That means the first clue that they have given is T equal to 3 by 4D. Now, what is the change in capacitance when the slab is inserted? Now, look at this. Okay, I will show you step by step. Tell me if you understand. See here. I know the formula for air capacitor is C is equal to A epsilon naught by D. And when a dielectric is introduced partially, can I say this is the formula A epsilon naught divided by D minus T into 1 minus, actually it should be 1 minus 1 by K or T into T minus T by K. Tell me, till here did you understand? This is the actual formula for a capacitance of air. But if I introduce something in between partially of thickness T, can I say this is my new formula? A epsilon naught divided by D minus T into 1 minus 1 by K. Again, from where did I get this formula? See this. This is the second case. I got my formula. Check. D has to be replaced by D minus T into 1 minus 1 by K. So I will use that formula, and they have given that thickness is 3 by 4D. They have given that thickness is 3 by 4D. Now, where they have given that, check this.
Sir, shouldn't there be K in the formula? A K epsilon naught upon T.
You can do that, but I'll tell you why. See here, you want to put K, you can put K, but first I will take air capacitor. Now, what is the formula for air capacitor?
Yeah, K will be 1 for air.
Correct. And even the table that we have seen, again, I'll show you the table. Everything starts from air. Check. In this formula itself, everything has to be changed. Correct?
Yes, sir.
Okay. Now, let me continue with that. Now, there's nothing more left. We just have to do math. Okay. I'm telling that because in this formula, I just need to put T equal to 3 by 4D. Now, if I put T equal to 3 by 4D into this formula again, A epsilon naught as it is, D minus, instead of T, I put 3 by 4D into 1 minus 1 by K. Okay. Now, first, I'll just go step by step, then you try to do it on your own. Numerator as it is, denominator, open the bracket. Minus 3 by 4D into 1 is minus 3 by 4D, and minus into minus is plus 3D by 4K. Okay. Now, D minus 3D by 4 is D by 4 plus 3D by 4K. Now, in the denominator, D by 4 is common. Inside the bracket, I get 1 plus 3 by K. D by 4 is common itself. LCM will be K plus 3 by K. 4 will go up, K will go up. Therefore, answer is this. Tell me, did you understand this? It is pure math and just simplification. Therefore, from this formula, if I put T equal to 3 by 4D, this is nothing but simplification of steps, nothing to do with physics actually. And this will be your final answer. So you also try to get the answer in a similar way. If you are stuck, you look at the
Can
screen.
you show me the question?
Yeah. This is the question. Now, can I see if I don't show you the answer also? Can you manage now? Can you try without seeing the answer? Try. Then again, I'll show you the answer, but try to get the answer without seeing the solution now.
Sir, that formula which I said you, in which we had introduced K, and I had asked you that why do we have K, but that formula is for parallel plate capacitor, right? And in the question they have mentioned it is a parallel plate capacitor.
Correct. So when they have mentioned parallel plate capacitor and they have said a dielectric constant K is introduced, that means before it was air capacitor. And once I introduce something like a dielectric, then it became a particular case. Do you understand?
We have to consider its initial form as air capacitor.
Yes. If they don't mention anything in the initial form, it is always taken as air capacitor.
So can you show the solution of this one, please?
So, sir, if we want in the final answer which we get, we can substitute K as 1, right?
K as 1 initially, but now they have said a dielectric constant K is introduced. If you see the starting of the question, okay, if you see the starting of the question, 1 minute, I'll come back to this. If you look at the starting of the question, what does it start with? A slab of a dielectric constant K, correct?
Yes.
So that means what? Before it was not there. Before that slab was not there. That means before what was there? Before air was there. Otherwise, they would say it has replaced some other K. They have not said it has replaced. They have said it is introduced. That means before it was air, now some K has come. That means that is why I've taken initial
The
case as
change
air.
has been offered.
Correct.
Okay, sir. Thank you.
Once you get the answer, just put one dot so that we can go to the next one. Any doubt in any step, let me know. We can simplify.
Done, sir.
MCQ 3, your next homework, make a note. Energy stored in a capacitor and dissipated. What is the ratio? Make a note. MCQ 3 is your homework. And MCQ 4, you will have to start now. Okay, so this is your homework. Start with this right now. Start with this. Logic is very simple of this MCQ 4 is start. Okay, now see here. I'll give you a clue. I'll give you a clue. See here. We have to find the work done in moving a charge along the circle CRD. That means finally I reach point D. So I have to find the work done in reaching the point D. Correct?
Yes, sir.
Now see here. Work done in reaching the point D. Do you know the formula W is equal to QV? Do you know the formula W is equal to Q
Yes.
into V? Now, is Q given? Which charge are we moving? Plus Q.
Yes.
Now tell me, look at the screen, everyone. Tell me, can I say potential at point D is nothing but potential at point D due to A plus potential at point D due to B? Why did I take only these 2 points? Because these 2 points have charges. Can I say potential is only affected by charges? Therefore, can I say, listen to me carefully, our final point is D, because when I move along the semicircle CRD, tell me where will the charge go finally? It will go over here, capital D, and which charge will go? Capital Q. Now tell me potential at point D, can I say is nothing but potential at point D due to point A plus potential at point D due to point B, because here there are charges. Now if I just find out that answer, I will get my final answer also. So look at the screen. Look at the diagram. I go from CRD. Okay. And I know that work done is Q into V. Correct? Look at it from this step only. Work done is Q into potential at point D. Why do I take potential at point D? Because my final point is point D. Now, can I say Q will remain capital Q itself because that is the charge we are moving? Check the question. Which charge are we moving? We are moving charge capital Q itself. And can I say potential at point D is nothing but potential at point D due to A plus potential at point D due to B. Now, what is the formula for potential? 1 by 4 pi epsilon naught Q by R, correct? 1 by 4 pi epsilon naught Q by R. Now, tell me at point A, what is the charge? Can I say at point A, the charge is Q? Therefore, can I say potential at A, that is 1 by 4 pi epsilon naught Q divided by the distance. Now, what is the distance between A and D? I have written it as 3L. Check how. From year to year 2L, from year to year L. Therefore, can I say 2L plus L is 3L? Tell me, any doubt in this? The distance between point A and point D is 3L. See here, L, L, L. Plus 1 by 4 pi epsilon naught. What is potential at point D due to point B? Now, where is point B? Here. What is the charge? Minus Q. Therefore, minus Q into what is the distance between B and D? The distance between B and D is L. Therefore, if I simplify this, I will get my final answer. That is it. There is no other complication. Now, the main thing from the diagram we should understand, what is the distance
But
between...
they haven't given the distance between AC.
C, you don't have to find anything because there is no charge at C. Potential will not get affected. Potential will only get affected with the charge. How many charges are in the question? 2, A and B. So I'll consider only these 2 points. Understood? Here there is no charge, does not matter. We don't have to consider.
Okay, sir.
Okay. Now looking at this diagram, tell me if you can clearly understand that the distance between D and A is 3L. From here to here is 2L. And B to D also will be L because it is a semicircle. So if this is L, even this will be L. Therefore, the first thing you should understand is the distance between D and A has to be 3L. And distance between B and D has to be only L. If you can understand that much, then this answer will be very, very easy. You don't have to do everything. You have to start from only this much. This is your answer. You don't need to do this. So this is your diagram. This is your answer. Tell me if you're getting it. Okay.
Sir, can you give me the hint for the third question which you have given as homework?
Which one?
Third question.
Oh, the third question hint will be equal.
Okay,
Third
sir.
question hint will be equal. I hope you got the answer there directly.
Yes, sir.
Now this question, all of you, I have shown the answer. Now you also try. Work done is Q. Next class is C. Yes, ma'am. Next class is C. Remember, our few table is very, very important. You should know that table completely by now. It was there in your 11th also and now also. Most of the problems, numericals make use of that table. Okay. So make it a point to know that table very well. Switch on your cam and let me know whether this problem is done.
Yes, sir. Done.
Done, sir.
This we have done it in one of the classes. Check. I think last class itself. Parallel plate capacitor, and we did this. Correct? Check.
Yes, sir. So can you show the question?
This is the question.
Sir, I
Start
don't think-
revising all the other topics from next week or from next week. We'll start with our one offline class. Okay, so all the topics that we have done, discuss it. I think Andheri first, and then
Sir, this one is done.
it is done. It is done. I was just showing you the question. We did this in the last class, correct?
I need to
Now,
find it.
I'll just go through the PDF again. Electrostatics 5. I'm giving you electrostatics 1, 2, 3, 4, 5 because each PDF has weightage of one topic. For example, from this PDF, if a question comes, it will be from either of the topics. Next PDF, it will be from either of the topics. So if you're doing a PDF, even though the topics look assorted means it looks different, you have to do the entire PDF because that PDF will give you that much amount of marks. Okay, now see this PDF 5, this is PDF 5, electrostatics 5. First, we started with potential. This PDF starts with dipole. I hope everyone knows the formula for dipole. 3 cases, and then we did the example of that dipole. Then we did this case. This we have done last class only, the 3 cases of parallel plate. Then we did this problem also in the last class. Energy stored in a capacitor, we did it today. And based on energy stored, we did one problem today. MCQ 1, 2, 3, 4, and 5. This 5th one, we have done it in the last class. So all MCQs you should be thorough with. Out of this, 2 are homework. Now let us start with the last PDF, which is Electrostatics 6. Okay, let me take it. Okay, now this is usually for MCQ. This might not come for your boards, but if you're MHT-CET students, then it is very important. Listen, we have done parallel plate capacitor, correct? We have done parallel plate capacitor, but there are other types of capacitors also. For example, there is something called spherical capacitor, and there is something called cylindrical capacitor. Now they have directly given you the formula for spherical capacitor and cylindrical capacitor. Therefore, spherical capacitor formula is this, and cylindrical capacitor formula is this. Now you just need to remember the formula. Very rare that you get a problem, but very, very common you get an MCQ on the formula. Always remember, B is the outer radii and A is the inner radius. That means A is the smaller radius and B is the bigger radius. And this is of cylindrical. So make a note, formula for capacitance of spherical and formula for cylindrical. Do we have the derivation? No. Do you have the derivation in the textbook? No. You have the derivation in a JEE module, but there also final result is there. Switch on your camera, everyone. So make a note of the first formula for a spherical capacitor and the second one for cylindrical. Now, everyone switch on your camera, quick. Now, you might be thinking capacitor means it should be 2 equal and opposite charge, correct? It should be 2 equal and opposite charge. So over here, there is positive charge. Whichever plate is grounded, that will have negative charge. So here it is understood that the charge is negative, outer sphere. Cylinder also, inner cylinder is positive, outer cylinder is earth. Earth means it was having negative charge. So draw this diagram of spherical capacitor, formula, cylindrical capacitor, formula. Start. Once you're done, please put a dot. Now, this is a very, very important table, again for an MCQ point of view. See here, they will say what happens to the capacitor when the battery is removed, or what happens to the capacitor when a battery is connected. So what happens to capacitance, charge, voltage, electric field, energy stored? Just look at this. When a dielectric is introduced and the battery is connected, so capacitance always becomes K times, either when battery is connected or when battery is removed. Okay. Now, if you look at charge, charge always remains the same. Charge always remains the same, whether battery is connected or battery is removed. But voltage, when battery is connected, does not change. But when battery is removed, decreases by a factor of K. Electric field also does the same. Just check. And energy, when the battery is connected, increases by a factor of K. And when a battery is removed, decreases by a factor of K. Now, this table, I want all of you to memorize, especially if you are doing MHT-CET and for boards. I have given this table because I have not given this table directly in the textbook. I have given it to you from the other book. But this table is important if you are going to do MCQs, because your boards, 12th boards, MCQs from the last 2 years. Last 2 years means 2018, 2019 have come from this table itself. Okay, have come from this table itself. Okay. For example, what is the change in charge when a battery is removed? Answer is charge remains unchanged. That way. What happens to the potential? Potential is what? V. Now, potential is V, that is voltage. It decreases by a factor of K. Okay, that way. So draw this table. As and when the questions come, I will tell you how you need to read the table. But the previous slide, this one, and this slide, mainly for MCQs. Okay, so make a note of this table. 5 quantities are there, and we should know what happens to them when battery remains connected and when battery is disconnected. Make a note, switch on your cam and make a note.
Sir, can you say the last slide for a second? Done, sir.
Very, very important table, okay? Considering the latest questions of electrostatics. Last 30 seconds, then I'm taking it out. Question is on the screen. Answer is also on the screen. You have to just read both and tell me whether you have understood. That's it. Nothing else. You have to read both and tell me whether you have understood. And message. Along the equator, we have just done that. Potential is 0, correct? V equal to 0 along the equator. And if V equal to 0, W also will be equal to 0 because W is equal to VQ. For that, you need to remember a very important concept that along the equator, your potential is 0. We have just done it in our last PDF. Along the equator, the potential is 0. Now, but this is a book back question. Therefore, answer, actually it is for 2 marks. So you have to know the final answer and why you got the final answer. That means 1 mark for telling that along the equator V is 0. And 1 more mark for telling therefore W equal to 0. Okay. So if you want to make a note and then we go to the next question. Finished?
Yes.
Next question and next answer both on your screen. Tell me if you have understood. All these questions are your book back questions, okay? These are not random questions. These are on the exercise page. They are saying if the difference between the radii of the two spheres is increased. Difference between the radii means B minus A is increased. Why B minus A? Outer radius minus inner radius is difference in radius. And if B minus A is increased, that means if the denominator is increased, can I say if the denominator is increased, the total term will decrease? If the denominator will increase, the total term will decrease. In this case, the total term is capacitance. Therefore, if B minus A increases, that is, if the difference between the radii increases, the capacitance decreases. This is the logic. Read the question, look at the answer that I have written and tell me if you have understood. This is how you write in the exam also. Check. And same way, if B minus A decreases, capacitance increases. If B minus A decreases, capacitance increases. I leave it on for some more time, then we go to the next question. Make a note. Homework, homework, homework. 3 questions. Make a note.
So these three are for homework.
Yeah, these 3 are for. Fourth one, I think we can do it right now. Tell me, fourth one we can do it right now because there is nothing to write. So fourth one will eliminate. Take only the third one and the fifth one as homework. Fourth one, tell me, what should be the answer?
Electrostatic shielding.
Electrostatic shielding is correct because electric field inside the car is 0. We have just discussed this, that electric field inside a charged metallic sphere or charged metallic conductor is 0. That is called as a Faraday's cage, or that is called as electrostatic shielding. Actual word is electrostatic shielding, because therefore when a lightning strikes, the safest place will be not under a tree, not over a tree, not over a car. The safest place to sit when a lightning strikes will be inside a car, because the car will act like a charged metallic conductor. So the charge will be on the outer surface of the car, and you know that electric field inside will be 0. Therefore, when you are inside the car, you will not get any electric field. Therefore, when lightning strikes, the safest place to stay is inside the car. Okay, and this concept, Tanush rightly said, this concept is called as electrostatic shielding. This concept is called as electrostatic shielding. We have done it in the first class itself. So fourth one, you don't take it. Fourth one, we have just discussed it right now. Take only the third one and fifth one as your homework. Okay. Make a note of the homework quick, then we go to the next page. Any charged metallic object, car, because we can go inside a car. Other things you have to go inside, right? That is why only a car in this particular case. Okay, Saitya. Okay. Sahitya, any vehicle, okay? Any vehicle. Car, bus, not a bike, because bike you cannot go inside. But anyway, okay? Yeah, tempo also. Okay? Now, torque equal to P sine theta. I don't think you have this in your updated syllabus, so we will not do this. Okay. Last question for your boards. Before that, look at this. question number 5. This is your homework, last homework for you. And for this homework, you need to refer the table that we have just done. When a battery is connected and when a battery is disconnected, what will happen, correct? Now you refer to that table and try to answer this theory question number 5. This is your last homework for this chapter. And after that, we'll do one last question. With that, we'll stop. Okay. Make a note of this homework question.
Sir, what about above it, the question above it?
That I'm doing it now. I'm doing it now. The question above it, I'm going to solve it now. All the answers of this particular question can be found on the table. In fact, if this question comes in the exam, you can draw the table as your answer. You will get full marks.
Okay, sir.
Okay. Now, last question for your boards. We'll finish this and then we'll stop for today. And this question is important. And this is important because it is a very common type of question. Okay. Now, this is the question. First, let me explain, and then you guys have to do it. They are saying, listen to this, they have not given the diagram in the question. Be very careful. And I want all of you to do this problem perfectly because it is the last problem, and after that, you're going to stop. So I want full attention for this problem. Okay, so take a blank page, be ready, and I want all of you to solve it and get this answer. Okay, do this one sincerely. 3 charges, minus Q, plus Q, and minus Q. Look at the caps lock. You cannot ignore the caps lock because capital Q is plus and small q is minus. They are placed at equal distance on a straight line, full stop. They have not given the diagram. So what I will do is I will assume that 3 charges, minus q, plus q, and minus q, as they are given in the question, they are placed at equal distance. So look at this. I will take this as my charge 1. I will take this as my charge 2. I will take this as my charge 3. Listen to me carefully.
Both are minus Q.
Minus Q, I'll take it as charge 1. Plus Q, I'll take it as charge 2. And this I'll take it as charge 3. And they are placed at equal distance, and let the distance be small letter r. They are placed at equal distance. So let me assume the distance is small letter r. Look at the screen carefully. Now, I will only tell you distance between charge 1 and 2 will be r. Distance between the charge 2 and 3 will be r. And distance between the charge 1 and 3 will be 2r. Tell me, did you understand this diagram from the first sentence of the question? They have not given the diagram. From the first sentence of the question, 3 charges are placed at equal distances. From this, I got answer as this on my own. Correct? Continue. If the potential energy of the system or the 3 charges is 0, potential energy means my work done. Correct? My work done is 0. That means if my total work done of the system is 0, they are giving me a clue that the work done of the system is 0. But before they give me that, do I know the formula for total work done in the system? Answer is yes. Please look at the screen. Can I say the total work done in the system is work done between charge 1 and 2 plus work done between charge 1 and 3 plus work done between charge 2 and 3, and this work done is 0. Did you understand this much? The total work done is 0. That means work done is 0. That means work done between 1 and 2 plus work done between 1 and 3 plus work done between 2 and 3, that will be 0. I have to find the ratio of capital Q by small q. Now look at the answer. I have to find the ratio of capital Q by small q. I'll just give you a hint. Look at this. Now what is W12? 1 by 4 pi epsilon naught. Charge at 1 into charge at 2 divided by distance. Now what is charge at 1? Q1. What is charge at 2? Q2. Now what is charge at 1? What Q1? Tell me. Minus Q plus Q. So can I say, do I know the distance between 1 and 2? Yes, I know the distance between 1 and 2 is r. Do I know the distance between 1 and 3? I know the distance between 1 and 3 is 2r. And do I know the distance between 2 and 3? Yes, I know the distance between 2 and 3 is r. So can you finish till here After that, I will show you the next slide also. But can you finish writing till here? Then we'll simplify together. Start. It is very, very simple. I've just shown extra steps. You can skip some steps and get the answer. Finish till here and then put a dot. Then we'll go to the next slide and get the answer. In the next slide, if you have finished till here, you just have to put this equal to 0 and continue substitution. Okay, start. Done till here?
Yes, sir.
Now, just tell me if you understand this. I'm just assuming you know this. If I put this equal to 0, can I say this whole term also, if I take it on this side, it will become 0. Therefore, this
Yes,
I
sir.
don't need to
Yes,
write.
sir.
Correct? Therefore, if I substitute this as 0, I can directly start with this. This will anyway become 0. Now, see the substitution on the next page. Tell me if you can understand this. It is done step by step anyway on the screen. See here, once this and this will be same, correct? Because minus q, q into r minus q, q into r is minus 2q into q by r. This will be as it is. This will be as it is. This will be as it is. This will go on the other side. Just it. Yes, I just showed you. I'm going back to the next slide. Okay, Saitya, let me know once you're done. Okay.
Sir, can you show me the last slide? Yes, sir, done, sir.
Finished, all of you? Finished?
Yes, sir.
Okay. Now, with that, we will stop for today. Next class, listen to me. Next class, 1, 2, 3. Next 3 classes means this week you will have 1 more class. It is not in the timetable, but they'll announce it. And next week you will have 2 classes. Okay. All 3 will be CET classes. So make a note. Next 3 classes, that is this week 1 class and next week 2 classes, will be pure CET classes. So boards students, you need not join. CET students, please make it a point to join. A very important chapter from your CET point of view, electrostatics. Okay, so we finished boards today. I will send the PDFs on the group. Link also I will send you of that earlier recording, and be ready for your CET class. Okay. So if you have no doubts, you can log off. If you have any doubts or anything to discuss, you can stay back. Thank you.
Bye, sir. Thank you, sir.
Bye, sir.
Bye, sir.
Bye, sir.
Thank you,
Thank you,
Prof.
sir.
Bye, sir.
Bye, sir. Thank you, sir.